Hi, here are some notes for section 6.3. We are going to continue to find zeros of polynomials. So just a quick review. In front of us we have a polynomial. It's a power of 3, so we would call this cubic. And we would call it a cubic 1, 2, 3, 4, a cubic polynomial of 4 terms. Okay, so just a review of that. So when we find zeros, the thing that we did in our last class is we first tried to factor out a greatest common factor when we saw a cubic. And if we look at all these terms, we hopefully initially recognize that the only factor they all have in common is the value of 1. And so that basically means that sometimes we can't use a GCF, but we still want to be able to find the zeros. What values, if I plugged in for x, would make this equation equal 0? So we know there should be 3 values of x that work because the exponent is 3. And if the exponent is 3, then we know there are 3 values for x that will make this function equal 0. So in order to start to find our zeros, we're actually going to have to use our calculator. So I'm going to pull up my calculator, and I'm going to type in the equation exactly as it is shown. So it's going to be x cubed minus 7x squared plus 14x minus 8. I'm going to hit zoom, and I'm going to go down to number 6. Zoom standard, so it's a 10 by 10 window, and I'm going to look at my graph. So it's cubic, so I know that it is snake-like, and I actually see that there are 1, 2, 3 places where it crosses the x-intercept. So what that tells me is in this problem I do have 3, and they're actually 3 real zeros. If you remember from our last unit that sometimes our zeros could be imaginary. And we talked about in class that if you wanted to find these zeros, they're also referred to as intercepts if they're real, you would use second trace and you'd find the 0. And you'd pick something to the left of that point. For example, 0's to the left. I'd pick something to the right, which looks to be about 1.5. And then I would guess. And it turns out that one of my zeros is 1, 0. If I find the other one, second trace 0, I want to find this next point right there, so I'm to the left of it. To the right of it would be a 3, and I'm going to guess, and my second one turns out to be 2, 0. 2, 0. 2, 0. And then I would repeat that process a third time, 0, and find this one. So here I'm to the left, to the right would be like 6. I'm going to guess it's around 4, and yep, it is 4. So my 3 zeros are all real zeros, and they're all rational numbers. They're actually all integers as well. And so we could find those using our calculator fairly quickly. So let's look at another example. Find the zeros of this polynomial. This one again is cubic, and it's a polynomial of 4 terms. So I'm going to go back to my calculator, hit y equals, clear that out, and type in this function, this polynomial. X squared plus 2x minus 1. And I'm going to hit graph. So it's cubic, so again I see that snake-like shape. I'm going to hit second trace 0. And I'm going to try to find this one. So something to the left would be like -5. Something to the right, -2, and I'm going to guess probably -3. And here what I recognize is that this 0 is not rational, meaning it's not a whole number, it's not a nice fraction. It is irrational. Okay, so what do? Well, we have to keep looking to see if there is an actual rational 0. And in all the problems that we're going to do in this next section, there's going to be at least one that's rational. So we're going to look again, second trace 0. Let's try that one. So I'm to the left of it, to the right of it would be 0, and I'm going to guess it's somewhere over there. And we now found a rational 0. Our rational 0 is -1, comma 0. There may be 2 rational zeros, because we did just see one where there was 3 rational, so I want to double check to see what that other one is. It's right here, so I'm to the left of it. To the right of it would be +2. And if I'm going to guess, it looks to be right there. And again, I notice this is irrational. I can't turn this into a decimal. I can't turn this into a fraction. And I could try. How do I try? X equals. So if I go back to my main screen and I just typed in X and pushed enter, there's my value. And so we learned that if you did math fraction, it would turn it into a fraction if this was indeed a rational number, and it's not. But what we did is we recognized that we can use our graph to find one rational 0. We know that there should be 3 zeros. And we saw when we looked at our graph that all 3 of them should be real, because 1, 2, 3 cross the x-axis. So there are 3 zeros and there are 3 real zeros. So how do we find the other 2? Well, what we first have to recognize is we have to recognize how would we write this as a factor. So if you remember our factored form, it was what did we solve to get this to equal -1? And if you remember, a factor of x plus 1 would give us back this 0. So we have to first figure out what is the factor that gave us our 0. Okay, the factor gave us this. And then the next portion, what we're going to do is, if you remember, well, all of these things multiplied in factored form, they all multiplied to give us our standard form. So if you know one thing that multiplies, if you divide that out, you'll know sort of what's rest. So if we're going to find zeros of a polynomial function, what we're going to do now is we're going to learn how to divide. How do you divide polynomials? And really, it's just going to review our long division properties that we learned. I think you learned how to divide in 3rd or 4th grade. So this is a factor that we know. So we start off that way. We start off with our factor x plus 1. We got x plus 1 because that's what you solved to get -1. And you are going to divide your polynomial by x plus 1. So how do you do that? Well, remembering your rules from dividing, you look at this value and you say, okay, how many x's would it take to get x cubed? Well, if I took x times x squared, that would give me x cubed. So what you do is you get x squared times x gives me x cubed. And then you have to also distribute it to this plus 1, so x squared plus 1 gives me plus x squared. And if you remember when you did long division back in 3rd grade, you then subtracted. So x cubed minus x cubed, 0. 4x squared minus x squared, 3x squared. Then you brought down the next term when you were doing long division. And then you went back to the original and you said, okay, what can I multiply x by to get to 3x squared? Well, I would have to multiply by a 3, and I'd have to multiply by an x, because 3x times x is 3x squared. 3x times 1 is 3x. Then you would subtract. This is 0. This gives me -1x. Then you bring down the next term. So we're just practicing long division. So what times x gives me -1x? Well, it would be a -1. -1 times x is -1x. -1 times +1 is -1. If I subtract those, I'm left with 0. So what we figured out is that we started with a factor that was rational, and we now have a factor that is a quadratic. So now what I have written is, this is my standard form. I've now written it in factored form. Now what we said last class was we would want to try to factor this again. So is there something that multiplies to -1 and adds to 3? Well, the only things that multiply -1 are -1 times 1, and that does not add to 3. So this is not factorable. Okay, so we're still trying to, our ultimate goal is to find zeros. So if you remember that when we find zeros, we've already found one right here. We found a 0. We found our rational 0 because we set each factor, this factor, equal to 0, and this is the one we saw in our graph. So one of our zeros is -1. We have to set the other factor equal to 0 as well. But we know it's not factorable. So our only method to finding an irrational answer, and how do we know they're irrational? Because, again, on our calculator, when we looked at it, these were irrational. So the only way to find an irrational answer is to use the quadratic formula. So it goes back to what we just did in formula, what we just did last chapter. So to find the other zeros, you do x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So you get -3 plus or minus the square root of 9 plus 4 over 2. So you get -3 plus or minus the square root of 13 over 2. So our ultimate goal again was to find the zeros, and we found them. One of our zeros, one of our values that will make our polynomial function equal 0 is -1. That's our rational one. Another one would be this irrational answer, -3 minus the square root of 13 over 2. And our third, since we know they're all real, but our third one would be x equals -3 plus square root of 13 over 2. So we know that there were going to be 3 zeros. Here are the 3 zeros. We know that one of them was rational because we were able to see that on our graph, and we know that 2 of them are irrational. And if we plug those into our calculator, what we would find is that if I did, again, -3 minus the square root, I'm going to do the plus one, -3 plus the square root of 13, all that divided by 2, it gives me the same answer, so I know that I did it correctly. So what we're doing in this unit is we are still finding zeros, just like we did in section 6.2, but now we're doing it for polynomial functions that don't have rational factors, nice whole numbers, they're going to be irrational, or when we solve our quadratic, or have imaginary. Okay, so after watching this video, we're going to do some more examples in class, but you could try working on some of the 6.3 problems or reviewing.